Hey guys, how's it going? So let's talk about worksheet 11-3, number 18, and I picked a problem like part B of 18. And so I have a cell that's not at 1 molar, so I'm going to have to use the Nernst equation. And it's asking me to find out the cell potential at this non-standard condition. And the temperature is the same, R is a constant, Faraday's a constant, so I'm going to use the equation that's taken those three numbers and condensed them all into this one. So now all I really need to know is the number of electrons being transferred and what ln of Q is. And so for that, for both of those things, I need to have a balanced equation. So one equation is going to be AU 3 plus goes to AU 0 plus 3 electrons. The other equation is Mg 2 plus goes to Mg 0 plus, oh, I've got the electrons in both cases on the wrong side, 3 electrons and 2 electrons. So, and this number is 1.498. and this is negative 2.372. This is a galvanic cell, so I have to have a positive cell potential. The only way to get that is if this equation is flipped. So I'm going to go ahead and rewrite both of them with this one flipped. So 3 electrons plus Au3 plus yields AU, and that is going to be 1.498. This is going to be Mg0 goes to Mg2 plus 2 electrons, and that's 2.372, and now it's positive. Now, I have to get the number of electrons transferred to be the same. So I'm going to multiply this one through by 2, and I'm going to multiply this one through by 3. I do nothing to these two numbers. This is the only time when I multiply by a factor, I don't also multiply the constant or the value by that constant as well. So I'm going to end up with 6 electrons, 2 and 2. I'm going to end up with 3, 3, and 6 electrons. So when I add up my equation, I get 2 Au plus 3 Mg solid. Oh, and this is 3 plus, and it is AQ. And the reason I need those AQs is because I'm going to have to do Q at some point soon. And so then 2 Au solid plus 3 Mg2 plus, and E naught for my cell is going to equal 1.498 plus 2.372 equals, and so I get that E naught is 3.870 volts. Okay, now I have to write my Q expression, and Q is equal to the products raised to the power of their coefficients divided by reactants raised to the power of their coefficients. So Q is going to equal the concentration of Mg2 plus cubed divided by the concentration of Au3 plus squared. And so in the problem I was given those two numbers. I don't have to do anything like multiplying by these factors. All I have to do is take care of these exponents. So Mg is going to be 0.85, and that's going to be cubed divided by Au, which is 0.65 squared. And so Q 0.85 squared divided by 0.65. And then I use a little caret and put in 3 equals. And I get that Q is 2.63. And that's one more significant figure than I have here, which is good, so that when I get to my final answer, it'll be straightforward. So I'm sliding it up a little bit. I think you can still see the equation. So E for the cell at this non-standard condition is going to be E naught 3.870 minus the constant 0.0275 volts divided, and this is in volts, divided by the number of electrons being transferred, which is here is 6 electrons. So I'm going to divide that by 6. And then I'm going to take ln of Q, which is 2.63. So in my calculator, I'm going to go ahead and take the natural log of that. Natural log second answer equals, and now I'm going to multiply that by 0.0275 divided by 6 equals, and so now I have that answer, and that's 0.0044. So 3.870 minus second answer equals my new cell potential is 3.8655 volts. And I had this to the third decimal place, and I only had 2 significant figures here. So at this point, I really don't care about your sig figs, but put in whatever you think is sufficient. Please don't give me the whole answer on your calculator. Round at some point. If you choose to stay with your voltages, that's fine with me. Okay, so I think that covers the question. If you have more questions, please email me. I'll be posting this right away.